you're ready to go. We are now recording. Let's get the PowerPoint selected. Sean is here. There you are. And Jarian's here. There you are. Has anyone else come in since the called roll? Okay. All right. Like I said, we are recording. Let's get the slideshow set up to the current slide. It's slow. I've got the same thing you do, a totally black screen. There we go. Beginning anyway. Now here's where things get weird. What you've got is not what I've got, so I've got to get this so it looks more like yours, because this is what's recorded on. Okay. Jessica? Is that right? All right. Anyone else come in since the call roll? Okay. Okay, maybe we're there. I think so. Now we've already done this problem, and we're going to start on 5, but 5 is not on the PowerPoint. So we'll use that screen. But before we get started there, were there some questions? Yes. Okay. I'm sorry? 58 on page 57? Yes. Okay. And this is on section 1.5. Okay. Now I'm going to write here, this has nothing to do with this problem. So let me get, okay. All right. So this is just to use the screen. This is page 57. Section 1.5, exercises, and this will be number 58, the one you said, right? Okay. It's awfully close, isn't it? Okay, is it exact? You sure? Okay. Awfully close, so let me see. Usually they don't do this. Usually they don't have number 10. Ah, yeah, you're right. It is a little different. Okay. But awfully close. Okay, here's 58. What it says to do in these exercises, graph the function and determine the intervals for which f of x is greater than or equal to 0. So we're first going to graph, then we're going to look for places where f of x is greater than or equal to 0. Intervals. Okay? Here is the function, 58. F of x is equal to x squared minus 4x. Okay? All right. Now, it says first graph. I will need a few points. Or, wait, there's several ways you can approach this. How would you like to approach it? Anyway? What would be your first, how would you start this problem?
Start graphing it.
Second?
Start graphing it.
Okay, how would you do that?
You can find points and plug it in.
Okay, so how would you do that? Okay, all right. So I take it you're going to sort of do a T-table? I guess they're called sometime. Can't write. Okay, now, this is what I was wondering. If, not that it matters, if you wanted to factor first. That just makes it a little simpler maybe. So let's factor it first. Does that factor? How? A little louder. Factor out an x, and what do you have left? X minus 4. Okay? And you want this greater than or equal to 0, but for graphing purposes, I'm really interested in where it's equal to 0. And where would that be? If this is equal to 0, where would that be? 4. So 4, we know this will be 0. You can plug it in and see. It works. And one more. Help me, help me. Where else is this equal to 0? Take it you got it from setting this equal to 0. What happens? Yeah, x equals 0. Okay? So there's another place. When x is 0, your function is 0. All right. Good places to start. And then why not pick something in between 0 and 4? What's a good number in between 0 and 4? 1 is a good one. And what do you get there when you plug it into f of x? -3. Okay? Let's pick something outside of 0 to 4. As, second? 5. Let's do 5. And what do you get there? Second? Okay, how did you do that? Height. Okay. 5. Okay, does everybody see that? Okay, how about something to the left of 0? -1, I like that. And what does that give you? A little louder. I hear a lot of mumbling, but I can't make anything out. It's all right to use pencil and paper, huh? 5, very good. Okay. Now, let's plot those points. Okay. Okay. I don't draw very even intervals here. Okay. I like one more. Exactly in between 0 and 4 is 2. Let's do that one too. What would that give you? -4. All right, good deal. All right, let's plot these points. How do I plot 4, 0? Say again? Over to the what? To the left? Right. Okay, right. Left, right, left, right. Okay, I'm marching. Okay. Next, 0, 0. I think I can figure that one out. Okay. How about 1, -3? Say that again. Okay, over meaning? Right 1 and down 3. Okay. I feel like a dentist here. Okay. 5, 5. What do you do? Right 5, up 5. 1, 2, 3, 4, 5. That's right about there. Next. -1, 5. Left 1, up 5. I think that was it. Right about there. And I did my 2, -4. I did that one right there. Okay? Let me tell you something. This is where I'm getting ahead of myself. Something about graphing quadratic functions. These are always a certain shape. Anyone know what that shape is called? Parabola. And parabolae, I guess it is, are always symmetric about something. Okay? So if you have, and by the way, the reason I chose the one exactly in between these 2 points, because they are symmetric to each other, one here is going to be our minimum. Okay? And since you have one here, guess what? You got one right over here too. And you see you got one here and here. So once you have that, it's real easy to go. So I know that if we had chosen 3, we'd also gotten a -3. Plug it in and see. 9, minus 12, negative 3. Got it. Okay? So here's our parabola. Now that parabola is f of x equal to that. Okay? Now, what we want to know is where it's greater than or equal to 0. Where would that be? You give this in intervals from, say that again. Okay, those are your x values. 0 to positive infinity. The f is negative down here and positive up there. That doesn't seem quite right. Where is it? Greater than or equal to 0? The f. The f is what? F of x is y. Where is your y positive? Greater than or equal to 0? From? But where your x is coming from? From what? Well, they're certainly there. Is that all the x's? Remember these parabolas? Negative infinity all the way up to, including 0, because that's on it. So it's greater for negative, let's see, infinity less than or equal to x less than or equal to 0. That's one way to do it. Or in interval notation, that would be what? Well, wait. I did something a little wrong there, and you didn't catch me. Shame on you. Okay? You never put equal to infinity. Okay? All right. Because infinity is not a number. Okay, so how would you put that in interval notation? The same thing I just said. Okay, negative infinity to 0. I'll buy that, but I need some sort of symbols around it. Parentheses on the left, bracket on the right. Because the equal sign means a bracket here, and since this is never equal to infinity, so that's always going to be in parentheses. Okay? Is that the only place f of x is greater than or equal to 0? So from 4 less than or equal to x less than infinity, how would we put that in interval notation? 4 positive infinity with bracket on the left, parentheses on the right. Got it. And we hadn't seen any like that, had we? Okay, nothing in the book, right? Okay, no, we had done a few of those, not that many. Does that make sense? All right, graph it first. Now, and the reason I factored it is, number one, to find my zeros. That's a good thing to graph from. But then also, sometimes it's easier to plug these numbers in to this than it is to that. So you don't have to square numbers, you just multiply numbers. 1 times negative 3 is negative 3. 5 times 1 is 5. You know, it's easy to do there. We're having a little difficulty on the big things, but you know, so sometimes it's nice to do that as well. Any questions? Does that make sense? Do you see what they're asking? No? Why not? Where are we missing? Well, give me something. Graph of the function, do you get that?
That was good until you got to like, when you started writing down the negative infinity is less than x less than or greater than equal to 0.
Okay.
So I was good until there. Now I'm lost.
Okay. All right. You told me what this stood for. What is it?
F of x is
Greater than or equal to 0.
0.
That's what we're looking for. What is f of x?
Y.
Y. So where are your y values greater than or equal to 0? Where is y equal to 0? Yeah, at the x-axis. And y is greater than 0 above the x-axis. So where are we looking? We're looking here. Here your function is greater than 0. Equal to 0 there, greater than 0 all here. Less than 0 there, leave that out. Equal to 0 again here. That's why those zeros were important. And then greater than 0 here too. The y's are positive. So that's what we're looking for. We're looking for the interval from negative infinity, less than or equal to, less than x, and x is less than or equal to 0. All here, your y's are positive. Here, they're not. They're negative. Leave that out, okay? Here, the y's are 0 again, and then positive from there on. So from x equal to 4 less than or equal to x to positive infinity, they're always positive. The y's are always positive. You're looking at the y's, but you're given the intervals in terms of x. Okay? Now, go back to, was the graph okay? Okay. Anything? What else? Anything? All right.
What would you use the U symbol between intervals?
Say that again.
The U symbol that you put in between intervals.
Okay. Oh, okay. Yeah, that's a union, and that would be perfectly okay to do here too. Is the union of this interval and that interval. That would be fine too. It said find the, what was the question? Graph the function and determine the intervals for which the f is greater than or equal to 0. So there's one interval is greater than or equal to 0, there's the other one. I guess it would be perfectly fine to do the union here.
You don't have to, though, correct?
Say again?
You don't have to, though.
You don't have to. It is acceptable. It said find the intervals, so there's an interval, there's an interval. So a comma is fine, but the union would be fine too. I'm trying to think where that's. They do have some situations where they definitely use that. And I can't recall if that's one in this section or not. But it wouldn't hurt to put it there. But when it's find the intervals, there's one, there's one. So whatever you put there. Yeah. But I think that would have been perfectly good. All right. Any others?
Number 77.
On same section?
1.4.
1.4. 1.4. 77. There we go. Difference question. All right. Everybody got this? Any question on this before I lose it? Okay. And I'll erase all the ink on the slide. And again, pick up here. That has nothing to do with what we're doing here. This is page 48. This is 1.4 exercise and number 77. All right. Says here in these exercises, find the difference quotient and simplify your answer. Okay, here's your f of x. X squared minus x plus 1. Okay? So find the difference quotient. Can someone tell me what the difference quotient is? Oh, they gave it to you. Sorry. They want this difference quotient. F of 2 plus h minus f of 2, right? Yeah. Divided by h. That's the difference quotient they're looking for. And of course here, you have to understand that h cannot equal 0. It can get close to it, but it can't equal it. Okay? So that's the difference quotient you're looking for. Now, if you're going to use this function to evaluate that difference quotient, what's something you got to do right off the top? Say again? Okay. Figure out what f of 2 plus h is. So let's do that first. F of x is that. F of 2 plus h would be what? 2 plus h squared. Notice what we're doing. Everywhere you see an x here, we're putting a 2 plus h instead of the x. So what's the next step? Minus, and I would keep the parentheses, 2 plus h plus 1. Okay, let's evaluate and see what that is. What's 2 plus h squared? A little louder. Okay, did I hear a 4h squared? Okay, all right. What does 2 plus h squared mean? It means 2 plus h times 2 plus h. That's 2 plus h squared, right? Now, can't you? Yes. Yes. Okay, that's absolutely right. There is a quick way to do it, like she just did, or you can do it this way. Either way, they're both right. 2 times 2 is? You're foiling it, right? 4. And then the outer is plus 2h. Inner is plus 2h. And the last is plus h squared. Okay? So you can, and then combining like terms, what do you have? Okay, it's running off the screen there and it's not printing well. Now, I don't know if Corey did it this way, but the shorthand way to do this, square the first, 4, twice the product of the 2. The product is 2h, double that, and you have plus 4h, and then square the last plus h squared. And that's what we got here too. Okay? Now, we really don't need the parentheses in front, so I'm going to take it out just because it's just taking up room. If I can get the pen to activate again, there we go. Now, next, minus 2. Say again? I can't hear. Plus h? Minus h. The negative distributes across the parentheses. Okay? Negative 2, negative h, plus 1. Okay? I don't think, oh yeah, there are some like terms here. What are they?
2 plus 3h.
Okay, wait a minute. You got this one, and that one are all integers, right? And what did that get? Second? Yeah. 3? Is that what I heard? Yes, okay. This high-level math sometimes gets us, okay? All right, next. The h terms, plus 3h, plus h squared. All right, that's your alpha of x of 2 plus h. Now we also need alpha of 2. Hopefully that won't be quite as bad. What will that be? Two squared minus 2. And what does that come out being? A little louder? 3. Excellent. Okay. So now we plug in what alpha 2 plus h is and alpha 2 up here, and that gives us 3 plus 3h plus h squared minus 3 divided by h. Right? What can you do to simplify? Yes, you can add 3 and minus 3. That gives you 0. And that leaves us 3h plus h squared over h. You can do this. Say again? Okay. You factor first and then you cancel. And when you factor out an h in the first, what do you get? H times 3 plus h over h. Now you can divide out. You're not canceling, you're dividing out. So your answer is 3 plus h. Now, remember h can't equal 0, but you can get as close to 0 as you want to. And the closer you get to 0, the closer that gets to 3. So ultimately that gives you that. And if, when you get to calculus, hopefully some of you do, when we take the derivative of this, that'll be 2x minus 1 at x equals 2. That would be 4 minus 1 is 3. What's that?
I don't like derivatives.
Oh, yes, we do. Oh, they're so much fun.
They're not.
Okay. All right, so that's what we get. Any questions on that? You see what we did? Any others? All right. If not, all right, let's get on to, let me clear this. Can I clear it now? Everybody got what they need? Okay. Let's get to example 5 in the section we're in, 1.7, page 71. It's another non-rigid transformation. It's compare the graph of each function with the graph of f of x is equal to 2 minus x cubed. So this is what we're going to be comparing with, f of x equal 2 minus x cubed. Well, first, we got to graph that one. And it seemed like maybe we did this last time, or did we? I teach so many different classes. I don't know. Okay, let's tick off some points here. It's sort of like hacking them off, but a little bit different. Okay. Now we might need to do some preliminary things, or we can just go, how do you want to graph this function? You choose. Got a couple of choices. How would you do it? How would you graph that function? Help me, help me. Say again? Okay, you want to pick some points? And x equal 2, is that your first one? Okay, sounded good. Okay, so we'll do x and f of x. F of x is equal to 2 minus x cubed. Now that's not one I can factor, so let's just pick points. You picked x equal 2, and what does that give you? X equal 2, what's your f of 2? Plug a 2 in here. Please excuse my dear X, I like to exponentiate first. 2 cubed is? Huh? 2 cubed is? 8. 2 minus 8 is? Negative 6. All right. Feel like a dentist. Okay. Give me another X. Feel like a cheerleader, huh? 1. Okay. What would that give you? 1. Fair. Very good. Give me another X. 0. Really? A little louder? Where'd you get that? Okay. You plug a 0 in for X. 0 cubed is? 0. 2 minus 0 is? 2. Okay. Positive 2. Okay. Give me another X. What? Oh, say again? I can't hear. Give me another X. Negative 1. All right. What does that give you? I'm sorry? 3. Excellent. Okay. Because a negative 1 cubed is negative 1, and minus or minus 1 is plus 1. 2 plus 1 is 3. Okay. Let's go to well, maybe one more. How about negative 2? What would that give you? A little louder? Okay. Did I hear a negative 8? Okay, when you cube a negative 2, you get a negative 8. So then a minus in front of that makes it a plus 8. 2 plus 8 is 10. So that gives you a 10. All right. I think we've got more than we can plot here because run off scale. So negative 2 is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Somewhere up there, negative 2 is 10. Next. Why did I start there? I don't know. Positive 2 is negative 6. 1, 2, 3, 4, 5, 6. That's down here. 1 is 1. That's right there. 0 is 2. That's right there. Negative 1 is 3. That's right there. And negative 2 is 10. So, this is our, and I was wondering if someone was going to do this. That's why I said you had several options. What you could have done was started with your parent function. What would your parent function on this be? Is what? That's not a square.
Oh, that's cute.
X cubed. Now, x cubed looks like this. Right? Starts negative, goes positive, flattens out near 0, and then goes positive. When you negate that, then it comes down like this, flattens out, and goes that. And then you elevate by 2, and sure enough, that's what you get. See it? So you could have done it by parent functions, or plugging and chugging and pulling teeth. It seemed to work. There is your function. All right. That's the one we're comparing to. Now what it says to do is compare these to it. Let me get a color. What color would you like G of X to be? Say again? Orange. Okay. I think. Yeah, I got it. So G of X, can you see that okay? Okay. G of X is f of 2x. Now what is that going to do for us? Oh, it was so long ago. 4 days. You can't expect to remember that long, right? What does it do to multiply your x by 2? What does that do for you? Okay. Hint. Non-rigid transformations. There's two things that non-rigid transformations that we've studied do for you. One is stretch, and one is shrink. What is this doing? Second? Shrinking. If this were 2f of x, that would be a stretch vertically. But remember, anything you do to x is backwards. Multiplying by 2 is not stretching it, it's shrinking it horizontally. Okay? So here's what you do. 0 stays 0. Okay? This one, horizontal shrink, it goes by a factor of 2, it goes here. The y value is the same, it's the x value gets shrunk by 2. And this one gets shrunk. This one gets shrunk, and this one gets shrunk. So here is the g function. Like that. A shrink, a horizontal shrink. An accordion player. It squeezes it in. Okay? That was G. What color do you want H to be? Choose a color for H. Second? Purple. All right. We'll go up here to purple for H. Okay? And our H of X is equal to f of 1/2 of x. What is that going to do for us? Any hints? It's what? It doesn't shrink. Remember, you're doing it to the x. Okay. Now, the first thing you may be able to do, since you're dealing with the x here, that means it's going to be horizontal, one way or the other. This was a shrink because everything with x is backwards. Multiply by 2, that's a shrink. Say again, dividing by 2 is a stretch, and it's going to double the x values. Keeping the y's the same, so guess what? The 0 stays 0, the y stays the same. But then when you go to this one, that was a 1, 1, now it's a 2, 1. It doubles the x, but keeps the y the same. Up here it's a negative 1, 3, so it becomes a negative 2, 3. Doubling the x, keeping the y the same. This one down here was a 2, negative 6. It keeps the y the same, but it goes to 4, negative 6. Double the x, keeping the y the same. This one up here was a negative 2, 10. Doubles that to a negative 4, but keeps the y the same. So this is now your g function. I mean h function. Okay? A horizontal stretch. Okay? Where the orange function was a horizontal shrink, this is a horizontal stretch. Make sense? Okay. See how the book did. Well, they didn't choose nearly as nice colors as y'all did. They're gray and black, but it works. The f of x is the gray, the g of x, and they actually multiplied it out. You didn't have to, but you could have, and that became a horizontal shrink, and then the h of x was a horizontal stretch. And sure enough, that looks pretty close to what we've got. They did it a lot shorter. Okay, any questions on that? Checkpoints here, well worth your doing. Okay, it sounded like y'all were sort of struggling with that a little bit. I would do your checkpoint as soon as you can outside of class. Okay? Let's look at the vocabulary. 1.7 vocabulary, top of page 72. Horizontal shifts, vertical shifts, and reflections are called blank transformations. Rigid, very good. Number 2, a reflection in the x-axis of y is equal to f of x is represented by h of x is equal to blank. Reflection in the x-axis. We don't have one here. The reflection across the x-axis does what? If you were up here and you come down here, what have you done? Negated something, what? You were up here, you come down here. What did you negate? The y value. And what's your y? Better get this right. F of x. So that would be h of x is equal to negative f of x. Okay? While a reflection in the x-axis of y is equal to f of x is reflected by h of x is equal to reflection across the y-axis. What are you negating? Say again? The x. So that would be f of negative x. In the first blank, the minus sign is outside because you're negating the y minus f of x. On the second blank, you're negating the x, so it's f of negative x. Okay, very good. Number 3, a non-rigid transformation, y is equal to f of x, represented by g of x is equal to c times f of x, is a blank blank when c is greater than 1. Okay, what are you multiplying by? The c? The c is being multiplied by the f of x. And what's f of x? You better get this right. What's f of x? Y. And when you multiply by y, c times y, it's a vertical. Because y is vertical. Now the question is it's a stretch or a shrink if c is greater than 1? stretch. So that would be vertical stretch. And a blank blank when x is less than c is less than 1. Vertical shrink. Perfect. Okay, number 4. Match the rigid transformation of y is equal to f of x with the correct representation of the graph of h when c is greater than 0. Okay? So A here is h of x is equal to f of x plus c. What is that? There's two things you should say. What orientation kind of your transformation is and which direction. So h of x equal f of x plus c. C is a positive number. What is that called? Number 1, are you changing x values or y values? Second? Okay, f of x plus c. F of x plus c. What are you adding to? F of x. And what is f of x? Y. And when you're adding to y, what are you doing? Vertical. Which way? Up. Yes. It's a vertical shift. C units up. So that would be little Roman numeral 4, right? H of x is equal to f of x minus c. F of x minus c. That's 2, a vertical shift, c units down, exactly. H of x is equal to f of x plus c. They sound the same, but you have to look at my parentheses. People at home can't see the parentheses. F of x plus c, what would that be? 1. That's a horizontal shift which way? Remember, if it's dealing with x's, it's always backwards. So a plus c would be to the left. So that would be little 3, right? And h of x is equal to f of x minus c, x minus c in parentheses. What would that be? It's what? The first one. Horizontal because you're adding or subtracting from the x, not from the y. So it's horizontal shift, c units to the right because everything you do to x is backwards. Okay. Homework exercises then, do either 5 or 7 or both. Do number 9. Do either 11 or 13 or both. Do any of the odds 15 through 19. Any of the odds 21 through 45. Now, hold on to those and look at those. What it's telling you to do is G is related to one of the parent functions described in 1.6. Identify the parent function. Describe the sequence of transformations from F to G. Sketch the graph and use the notation to write G in terms of F. Okay, so that's giving an equation. You write down in words what your changes are, your transformations are. Okay? Now, 47 through 53, notice what there is. They're giving you the words. They want you to write the equation. Okay? So in this one, write the equation for the function described by these. So these are inverses of each other. One, they give you the equation. They want you to write the transformations in words. The second one, they give you the words. You write the transformed equation. Got it? You notice I'm spending a lot of time with this? Does that suggest anything? You may see it again. Hint, hint. Okay. Then do either 55 or 57 or both. Then any of the odds 59 to 63. and do either 65 or 67 or both. Then do 69. Good problem. I would definitely look at your true false, 71 or 73. You can look at all of them if you'd like to. Make sure you understand why those are true or false. Don't expect to see many like that on the test, but that should give you your concept good. And 75, good thing to look at. 77 to look at. You don't have to do those. Describing profits, 79, those are pretty practical problems. Any questions? All right. If no questions, then let's move on to 1.8. Okay. So let's end this and go to 1.8. All right. It takes a while to load. It's just sitting there quivering now. I don't know what that's all about. Okay, here we have it. And we'll go slideshow to current slide. And it gets off its black screen. Then I have to change the view. You don't see it, but I do. And go through a bunch of function keys. Got it. All right, we're still doing functions and their graphs. Graph, okay? Why this changes, I don't know. But we're going to be combining functions. Let's see if this does anything. No, it doesn't. Okay. Combining combinations of functions and composite functions. Now, what we had in 1.7 was transformations of functions. Okay? Now we're going to be combining functions. Now, the first of these are pretty simple. Adding, subtracting, multiplying, and dividing functions. Pretty straightforward, especially the first three, okay? With dividing functions, you have to be sort of careful about your domain because now usually you're putting an x into the denominator. Those are always a little dangerous. But if you're careful, you can do it. We'll find the composition of one function with another function. That's a sort of a new concept, okay? And then we'll use combinations and compositions of functions to model and solve some real-life problems. We can't wait. Let's get the skills down first. Arithmetic combinations of functions. These are your additions, subtractions, multiplications, and divisions. All right. Just as two real numbers can be combined by operations like adding, subtracting, multiplication, and division to form other real numbers, two functions can be combined to create new functions. Right? Makes sense. For example, if you've got one function, f of x is equal to 2x minus 3. Here's another function, g of x is equal to x squared minus 1. They could be combined to form a sum. That would be f of x plus g of x, which is simply 2x plus minus 3 plus x squared minus 1. And when you add those together, now here's a few hints. When you're writing these down, not a bad idea to put parentheses around this function plus that function. That's what it's saying, okay? But when there's nothing in front of parentheses, you can lose it, both of them, okay? This one, if a plus sign is in front of parentheses, you can lose the parentheses. It doesn't contribute anything. If that's a minus, like when we get a difference, then you have to be careful. So here we're just combining like terms, x squared plus 2x minus 3 minus 1 is minus 4. That's all there is to it. Okay? Now, we haven't talked about yet, we're going to. Whatever your domain of this function was, when you're adding it to this function, you have to consider domains. You have to stay within what's common to the two domains. But what's the domain of this function, unless you're told otherwise? All real numbers. And this one? All real numbers. So your sum domain is all real numbers. So usually with adding, not a problem. Subtracting, not a problem. Multiplying, not a problem. Okay? It's when you divide you have to be more careful. So if you do f of x minus g of x, now again, this set of parentheses doesn't really help you much. This one is important. parentheses here, but here what do you do? Distribute the minus sign across the parentheses. That becomes a minus x squared plus 1, right? Remember that. So you wind up with a minus x squared, and you have a 2x, no, just a plus 2x, so that's fine. And you have a minus 3 plus 1 is minus 2. So be careful. This will reach out there and bite you in some unknown part, half the time. So be careful about those signs. Okay, what if you're multiplying two functions? Just take them and multiply. How would you multiply those two? Curses. Fold again. Okay, fold this. Two x squared, you have x cubed. Okay, now I'm going to misspell it now because I like to do the squares next. Minus 3x squared minus 2x plus 3. Just multiply them like we've always multiplied functions. Now, again, with adding, subtracting, and multiplying, if you had all real numbers here and here, you have them here. Here and here, you have them there. Okay? But when you're dividing, you have to be careful. Okay? You do your f of x divided by g of x. What's your problem here? You cannot have a 0 in the denominator. When would x squared minus 1 equal 0? Either x equal plus 1 or x equal minus 1. So you have to eliminate both of those. So as long as you eliminate those two, this is your quotient. Okay? So notice this. Usually if there's no limits to your domain of f and g, adding, subtracting, multiplying are not going to change anything. But when you're dividing, you have to make sure that whatever you do in that denominator doesn't produce a 0. This one, x equals plus 1 or minus 1, even though it's fine here and here, it's not fine there. So you have to eliminate those here. Other than that, there's your quotient function. It's easy to write down. You have to think a little bit about the domain, right? All right. The domain of an arithmetic combination of functions, f and g, consists of all real numbers that are common to the domains of f and g. Now let's say that f was defined from negative infinity up to 4, say. G was defined from negative 1 to positive infinity. When you add, subtract, or multiply, then you're restricted to what's common to both. So let's say negative 3 to 4, or whatever it was. Whatever is common to both. You can't use these if it wasn't allowed in G. You can't use those if it wasn't allowed in F. Okay? So, you use what's common. Now, if nothing's common, you can't do them. Okay? In the case of the quotient function, though, you still have those restrictions, but there's a further restriction that your g of x can never equal 0. So you find out any values of x which will make that denominator 0, and then you also eliminate those. Okay? That's the only issue with combining functions, keeping up with your domains. Okay? And if the domains are fine, it's a piece of cake. So here's the summary of that. Sum, difference, and quotient of functions. If f and g are two functions with overlapping domains, if they don't, domains don't overlap, you can't do them. You can't combine them. But if they do, is it time? Okay, I know it's so much fun we hate to leave, don't we? Is it? Huh? 2 more minutes. Okay, so I think we can finish this slide. So for all x's common to both domains, the sum, the difference, the product, and the quotient, you have to worry about the quotient of f and g are defined. The sum of two functions, f plus g of x, is the sum of the functions, f of x plus g of x. F minus g, that's the difference function, is the difference of those two functions. The quotient function, f g of x, is f of x times g of x. And the product function, the quotient function, f divided by g of x, is f of x divided by g of x, as long as g of x is not equal to 0. All right. we will start with example 1 next time. I don't think we got enough done to get any new homework exercises. We'll start. Yeah, if you're finished with your quiz, I can take it. If you need more time, you certainly can do it. Did everybody get a copy of the quiz? Oh, in the paper. Excellent, excellent, excellent. Huh? As soon as you can get it in. Okay? Okay. All right, good deal. Thanks. Okay. They are really valuable. Hang on to it as long as you can. All right. Okay. We'll start here. I'm sorry? Oh, you need a quiz? Okay, just a second. Let me do this before I forget it. Okay. You don't turn yours in? Okay, good deal. All right. Do you need graph paper? You don't need it? Okay. For some reason, I've got the graph paper on top there. Quiz one. What's that? Oh, we'll have as many as we can squeeze in. Oh, it's very good. We missed you Tuesday. Thursday. We were worried.
Yeah.
Up there.
Heart trouble.
Oh, I see. That happens. In the best of families, yeah. All right, take care.